anything. So the homework was leave one side of the screen, come up on the other, and then have the player slow down if you're not pressing any keys. This one. Okay. So where you kind of should have been after our lab from last week should have been a ship that could rotate and move and accelerate in a direction. However, that ship unfortunately does not slow down. And also when you go off the edge of the screen, you don't come out the bottom. So let's do the first part of the lab, which is to have the ship appear on the other side of the screen. And this is actually pretty similar to how we handle the ball bouncing around in Pong. So if you remember back to Pong, the ball, while it was moving, you check to see if it was out of bounds on the top or bottom. And if it was, you would just reverse the velocity of the ball to make it bounce. And if it went off the left or right, you would give a point to the side that scored. And so it's the same concept here where you can treat this ship kind of like how the ball is treated, where while it's moving, you can check the position of the ship. And if it's either off the left side of the screen, which would be 0, or the right side of the screen, which in this case would be 1280, or the top and bottom, which would be 10 and 720 respectively, you want to actually just do some behavior. You want to actually change the position of the ship. So what we're going to do is we're going to go into the code that actually moves the ship. So right here, this is where we move the ship based on velocity here. And we talked about limiting velocity. Remember, we grabbed the distance. This is all stuff we did last week in class. We're going to keep that stuff the same. The only difference is that now, after we have moved the ship, we're going to figure out whether the ship is off one side or the other. So why don't we start with a simple thing, which is to see if the ship goes off the left side to have it move to the right side. So if all you do is you compare the position of the ship, and if it's less than 0, that means that your ship is beyond the left edge of the screen, which means now what you can do is you can set the position here to be on the right side of the screen. This is it. Like if you move off the left, you put it on the right. By changing this position here, you're also going to be updating the sprite position down here of where the ship is. So I'm going to just do that one if statement and move off the left and make sure that works correctly. And so now I appear on the right side. And really all it is just me just changing the position of the ship. So I can repeat this pattern for the top side as well, because I know that's pretty straightforward. If this is less than 0, that means I should appear on the bottom side of the screen. Cool. And we just have to do it for the bottom too, because right now when I go off the bottom, I don't come out the top. Okay. So why don't we write another condition here? If the position of y is greater than 720, equal to 0. The key is that this is greater than, not greater than or equal to, because if you make it greater than or equal to, you'll get into a really weird situation where you might get stuck because you might teleport off the top, get set to 720, and then next frame you might actually end up right here again and then get teleport back and forth. Okay. And this is another else if. Okay. So this behavior here will now control all 4 sides and will let me go out any direction, and I won't be afraid to get lost. All right. So let's do the drag portion. So there are several ways you could do this. However, the way that I was imagining this working was that anytime that you're not currently accelerating with the ship, like you're not pressing up, that the ship would gradually slow down over time. And gradually slow down is different than coming to immediate halt, as well as slowing down linearly. So what I want to do is introduce the concept of drag, which is kind of like an acceleration, but it's in reverse, right? And drag is like the faster you're going as well, the faster you slow down. Means that if you're moving like at near the speed of light, you're actually going to be slowing down much faster than if you were moving like 1 mile an hour. Like the amount of speed change from second to second is a lot bigger the faster you're going. And to that effect here, what I'm going to actually do here is I'm going to write a function. So next to limit velocity, I'm going to write another function which lets me basically apply drag right before I change the position. This is where I take the velocity and I move the ship based on it. So I'm going to make another function here that's going to be virtual. It lets me apply drag to the ship. So if I go back to the header file, I have this function here, limit velocity, and all I really want to do is make another function that's called apply drag, which takes delta time as an argument. And I'm going to take this whole thing, I'm going to scroll down to where it calls limit velocity, and I'm going to implement this function here, delete the virtual keyword, and I'm going to call this function here. So every frame I'm going to be applying drag. Now this is important because I may want to apply drag, I want to apply drag every frame because it changes the velocity every frame. And in our case, we actually only want to apply drag if you're not currently pressing a key. So in this case here, what I can do is, if the acceleration is equal to 0 in x and acceleration.y is equal to 0, I can consider applying drag. And just to start here, I'm just going to do a cout and say applying drag. And include, I'm using cout here because I want to know that I'm applying drag at the right time. Like I'm only applying drag if I'm not pressing the key. So I should see it applying drag immediately. And then if I push forward, you see it actually stopped moving, and then now it's going again. So as long as I'm pressing the key, it's not applying drag. So I've proven that my function is getting called, and I can now write my behavior inside this function. Now, a kind of naive way to do this would be just to go ahead and say, hey, m velocity, oops, where's my player? Here we go. When I'm applying drag here, I can say, hey, m velocity dot x minus equal to like 10 times dp. This is not actually the same thing as like applying drag. This is just slowing down the ship at a linear rate. And it actually doesn't even work correctly if I'm moving negative. So I'm just going to go ahead and say like this might be the way that you're thinking about doing this, but I'll show you how this works. I'm going to show you how we evolve from this to actually make it use drag. Okay, so what I'm doing here is I'm taking the velocity, I'm subtracting 10 every second, as long as it's greater than 0. So if I start moving down and to the right, we need to make sure it's actually doing this thing here too. Let's do a standard cout. I'm not convinced it's actually doing this. Velocity.y. Okay. So it is actually slowing down the ship. You guys can see it actually comes to a stop. And then starts kind of moving up and backwards a little bit. So this has a few flaws, and actually it's more involved because you have to take into account the fact that you might be moving negative, in which case you actually need to apply drag in the opposite direction. So there's a little bit of an easier way to do this. The concept of drag is that you want to reduce the velocity by some factor of the velocity itself. Like you want to say, hey, depending on how fast you're moving, you want to actually reduce it by that amount. So if I create a variable called drag, and I take into account the fact that I know how fast my velocity is moving here, what I can do here is I can take my velocity, which is my current speed, and if I just multiply it by 0.9 times the velocity, this gives me some amount that's relative to the velocity. It gives me 90% of what my velocity currently is. And this amount here is going to act as how much we want to slow down our ship by. And if all I do is I multiply this by delta time, this means that I want my ship to be slowed down by 90% every second. Okay? This is the same concept as multiplying the speed by delta time. It's taking, hey, take this percentage of my velocity and apply that every second. And so all I need to do here is take my velocity and subtract the drag from it. This drag is already going to be a pretty small number, but this number will be bigger the bigger my velocity is, right? And it'll be smaller the smaller my velocity is. And the nice part about this is that actually it also applies a nice smooth curve to my velocity, and it also doesn't care what direction I'm going. So if I wanted my thing to slow down like that, it's slowing down by 90%. It's slowing down to 90% of its speed every second. If I want this thing to slow down faster or slower, this thing will slow down almost immediately. I'm sorry, this thing will take a lot longer to slow down because it's only 10% of the speed. But if I want this thing to slow down a lot faster, like 98% of the speed, that means second to second, I'm reducing my speed by a huge amount. Every second, I'm reducing it by 98% of what it currently is, right? So it takes about like 3 seconds to come to a complete stop. A little bit more, a little bit less. And then if I do this, this could also just be 1. It'll take a little over a second to come to a complete stop. Okay. And if I make this thing like 4, it's almost like it has brakes on it because I'm just letting go. Yeah. Okay. So this number here is effectively, this is my my friction. Okay. So the higher this number is, the more friction I have, so the faster I slow down. All right? Questions?